Well, all my problems are invisible to me. This is 1262 greatest sum divisible by 3. All right, let's go ahead and get right into this problem. So you're given an integer array nums. Return the maximum possible sum of elements of the array such that it is divisible by 3. Pretty simple problem description, right? Just one sentence. This requires some knowledge about, integers, discrete mathematics, divisibility, all that jazz. But essentially all you need to know is when something is divisible by 3, what does that mean? Well, for any number x to be divisible by 3, that just means that x mod 3 equals 0. And mod, right, is the remainder, which makes sense when you think about divisibility, because what does divisibility mean? Divisibility means that, 3 is a factor of that number. So if 3 is a factor of that number, x mod 3 will equal 0. So that's what divisibility means. When we look at this sum here, right, if we pick numbers 3, 6, 1, 8, and sum them to 18, it's divisible by 3, right? Because 18 mod 3 is 0, because 18 remainder 3 is 0, because 18 equals 3 times 6, right? So since 18 equals 3 times 6, therefore 18 mod 3 equals 0, because 3 times 6 mod 3, well, obviously 3 goes into this, and it actually goes into both factors, but that's, not important, equals 0. So hopefully you understand how modular arithmetic works, how divisibility works, right? Sometimes people say, you don't need any math knowledge to solve Leetcode problems. You need some math knowledge, right? You need to understand some things because you need to understand, these definitions like what is divisibility, what is modular arithmetic, etc. And actually having a strong modular arithmetic background will help you solve this problem. Why? Well, let's just go through a little proof which kind of leads you to the intuition you need to solve this problem. If you have x, right, you can think of x, any x, right, and x to be divisible by 3. Well, x in the context of this problem is the maximum possible sum, right? So we're trying to find a subsequence, kind of, right? Because we're trying to pick elements, right? We're just trying to pick a series of elements such that when we sum them up, then divisible by 3 equals 0. So let's say x is that sum, right? So x is going to equal, for some generic or nums, so let's say nums just generically, let's use a very generic argument to try to build our intuition. Let's say nums equals x1, x2, x3, x to the n. Okay, so I'm just saying a very generic system, okay? And let's say our solution is x, and x equals some sum of elements, right? xi plus xj plus xk plus xz, whatever. What I'm basically saying is our solution, x, is the elements that we've chosen such that when they're modded by 3, right? When this system is modded by 3, it equals 0. Okay, so in this case, right, our nums are 3, 6, 5, 1, 8, 3, 6, 5, 1, 8. And then our x is 18 because we choose numbers 3, we choose number 6, we choose number 1, we choose number 8, right? That's a specific example. I'm trying to generalize that so we can build some sort of intuition about the nature of this problem. So this problem is very mathematically inclined, right? It's very mathematically involved. You need to have a strong intuition about mathematics in order to, at least modular arithmetic, to convince yourself of the solution. At least I did. That's the path I took. Maybe there's an alternative route where you can think of this in different terms, but mathematics describes this problem very well. Okay, so if x mod 3 equals 0, right, that's our solution. X is the sum of characters. So that means that we have the case that x mod 3 equals 0. Well, that's just the same thing as saying xi plus xj plus xk plus dot 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 plus xz mod 3 equals 0. Right? Now, I guess something you should know about modular arithmetic is that the distribution property is kind of interesting. Right? I can take these messages, I can take these numbers, and I can distribute the modular like this. Mod 3, these elements, plus dot, 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 dot. Everything in here also gets modded 3, plus x to the z mod 3. All of this system mod 3. Right, so in the context of this problem, right, if I choose 3, 6, 1, and 8, right, that means that 3 plus 6 plus 1 plus 8, I'm looking at this particular example to try to kind of convince you of this argument here, right? Of course, you can't prove something with an example, but it can also give you intuition. So I'm not proving anything. I'm just saying that it is that without proof and giving you an example so that you can use that to justify it to yourself. Okay? Right? This mod 3 has to equal 0. But you can split that up into 3 plus 6 plus 1 mod 3 plus 8 mod 3 equaling mod 3 equaling 0. So what that basically means is, well, 3 plus 6 plus 1, that's 10 mod 3 plus 8 mod 3. What's 8 mod? We'll just leave it like this for now. Mod 3. Well, 10 mod 3 is 1, and 8 mod 3 is 2, because 3 goes into 8 2 times with 2 left over, right? And 3 goes into 10 3 times with 1 left over. Mod 3, which equals 3 mod 3, which equals 0. All right, which kind of makes sense, right? Because you're just trying to find the remainder of this system. So if the remainder of one component of the number plus the remainder of another component of the number, you can modulate those individually and then mod it with the end and get your final solution. So how does this relate to our problem? How does this idea of saying, well, I can split the system into 2 mod 3s help us with this problem? Well, I guess the idea is here, which is where you have to make the biggest leap, is that, you know, you can keep track of the maximum possible sums at each mod, and then when you're given a new number, you can discover where it should go. What I'm basically saying is, like, if you look at any previous sum of elements, right? So if you had the previous sum of elements, xi plus xj plus xk, and you wanted to add an additional element, let's call that x L. Well, if you knew the mod 3 values of this system, right, if XL mod 3 was 0 and this was 0, 1, 2, 0, 0, 0, 1, 2, 1, 1, 1, 0, 1, 2, 2, 2, 2. Saying if xi plus xj plus xk mod 3 equals 0 and 0, what is the whole system going to be? 0, 1, 2, 1, 2, 0, 2, 0, 1. So if you add up these two components, the mod 3 of this system with the mod 3 of this system, and you mod 3 it again, so we're basically we're exhausting all possible possibilities of this problem here. If we apply that to this system, right, you'll notice that if a previous sum mod 3 is 0 and the current number mod 3 equals 0, your whole sum mod 3 is 0. If the previous sum mod 3 is 2 and your newest number happens to be a 1, now you get a new sum where the mod 3 is 0, right? And if your oldest number mod 3 is 1 and you add a new number and its mod 3 is 2, you get a whole sum of 0. So the reason why this previous part is important is that every time you add an additional number, right? Every time you add this new number, if you keep track of the largest sums, modular 0, 1, and 2, you can know what the greatest sum you can get is using this number in both of those mod spaces, right? Because like if you have the last number is mod 3 and it's 1, if you have a really large sum that's mod 3 is 2, you can just add in this element and you'll get a new sum which mod 3 is 0. So if you keep track of those largest sums, you'll be able to find the maximum mod 3 0 system. So basically if you have a number, right, xi, and this is your newest number, so you've already processed let's do this here. Using all of our previous ideas. Hopefully this makes sense. I'm kind of going all over the place. So hopefully in the end things connect. So say you've already processed, you're looking at this number, right? Now you can do this for any digit, right? I'm making this case for any digit. Let's say you found x bar 1 equals the largest sum where x bar 1 mod 3 equals 0. Or we'll call it x0. X bar 1 equals the largest sum where x bar 1 mod 3 equals 1, and x bar 2 equals the largest sum where x bar 2 mod 3 equals 2. So what I'm basically doing is I'm saying, when I process the system before I get to xn, I'll keep track of the largest sum, x bar 0, where its mod equals 0, and x bar 1, where the mod is 1, and the x bar 2 and the mod is 3, right? Because that means I'll have some set of this system in here, right? For each of these, I'll have some set of this system in here that I'm going to attach this final number to. And using this idea here, right, I'll have this sum system here for the largest system where mod 3 equals 1, mod 3 equals 2, mod 3 equals 0, and I can attach this final number to make a decision about where things need to go using this idea, right? So the first case we have is XL equals, if the newest number equals 0, so using this system bar here, let's see if we can get things closer together. Okay. Problem is now my face is in the way. Okay, it's fine. So I'll do it here. So if you look at your newest number, right, we're talking about xn. So I'm adding xn to this system, right? If xn mod 3 equals 0, we're in this case, right? So the longest sum is now what? Well, if any sum before, my maximum sum, largest sum was 0, if I attach my newest number, its mod space will still be 0. So that means that our x0 is it's going to be either what it was before, because maybe including this number doesn't increase it. Well, it would always increase if it's x. It doesn't matter. We'll just leave it like that. We don't need to use max for this. Okay. So x0 now is, well, the largest sum with the modular ending in 0 is whatever it was before plus this new number, right? And that goes the same for all of them, right? If you look at this system, if the last system's mod was 1 and you add something mod 3 0, that's still mod 3 1. Okay, so that one's not that interesting. Now let's look at the mod 1 case where the remainder is 1, right here. So what if xn mod 3 equals 1? That looks really weird, sorry. Well, x1, the largest of x1 now is, well, if this thing mod 1 is 0, if I add in something previously that was mod 0, it'll become 1. right? So that means that x1 equals x0 plus xn. But it may not, right? Because maybe there's a previous sum that's larger that uses x0, right? So maybe I don't want to use x0 plus xn. Maybe adding this element to x0 using xn makes x1 smaller than it used to be, right? Because we just want the largest sums ending at any modular. So if we take the max of that and whatever x1 was before, okay? And then what about x2? The max of, well, to get x2 when you have remainder 1, right? 2 remainder 1 is when you add it to something that already had a remainder 1. So you do x1 plus xn, x2, x3 equals the max of x2 plus xn, and, okay, x0, x0. Looks like I was writing some characters. And then the same thing for if it mod 3 equals 2. Well, you're kind of noticing a pattern here. The max of x0 plus xm, x2, and I'll just quickly go through all these. x1 plus xm, x0, x2 plus xm, x1. Okay, so this is all three of them. So basically, if I know the longest sums, right, I know the largest sums using the previous elements, when I add in an additional element, it'll change the largest sums mod anything depending on what that number is itself mod something, right? So if x of n, the newest number mod 3 is 0, well then now my largest sum, meaning that the largest sum is the number of elements, that the sum of the elements that I'm using to get something modular 0, I add in my newest element, right? It'll now be including xn, the one using 1, including x1. Sorry, that doesn't make sense. If I have my newest number, right, and it mod 3 equals 1, well then I can attach my 1, since xn mod 3 equals 1, if I attach it to something with mod 3 equals 2, right, so if this system has mod 3 equals 2, that would mean that basically what I'm saying in this case here, if this doesn't make sense, this proof here, right, this case happens when xn mod 3 equals 1. So if I add it to something, right, if I add it to something here where x2 mod 3 equals 2, well, if I add these together, right, I get 1 plus 2 equals 3, which mod 3 equals 0, right? So if I take x, which I know, sorry, I messed up there. If I take x, which I know mod 3 equals 1 because I'm down this case, and I add it to x2, which I know mod 3 equals 2, together they'll get mod 3 equals 0. So I can increase whatever I think my largest mod 3 system is equaling to 0 here by using this new system, or I can use whatever it already was because maybe it's better before. Okay, so with all that craziness done, let's go ahead and do the sample problem again by hand and see if the intuition we can get works, okay? So what we'll actually do is we'll keep track of the system. So we have 3, 6, 5, 1, 8. Now I'm trying to think about how we're going to do this so it's as clean as possible. So we'll keep track of x0, x1, and x2. We'll keep track of the actual numbers that we're using, even though in reality we'll just keep track of the sums. So the first number we look at, right, is 3. So one note we have to do is say, well, like, we'd say that x1, whatever it was before, plus 3 would still be x1. But since there's nothing in this spot, we can't put a 3 here, right? We could put a 3 here if there was something already here, right? Because if we add in 3, then we get 4, so it would be mod 3 equals 1. But since there's nothing there initially, we can't put that in the spot. So that's something to keep track of. So 3 mod 3 equals 0. So we'd add that to this spot here. Then we look at 6. Again, we'd have to add it to this spot here. Now it's where it gets interesting. We look at 5, right? So 5 mod 3 equals 2. So let's look at this problem. So 5 mod 3 equals 2. So we're going to go down this path. Right, 5 mod 3 equals 2. Well, now, since it's mod 3 equals 2, we can add ourselves to x0. Right, because if x0 is something mod 3 plus 6 is 0, so mod 2 would mean that we can just add ourselves to that system. Right, so if we take something that's mod 3 equals 0 and add something in that's mod 3 equals 2, like the 5 that we're looking at, now the system will be mod 2. In order to be mod 1, we'd have to add it to x2. But since there is no x2, there wasn't any x2 when we added it in, right? We can't add it here. And then for x0, we'd have to add in x1, right? Because something mod 2, but there's nothing here. There was nothing here as well. So you can only update this system. So let's look at 1, and hopefully it makes a little more sense. I should have included that 0 idea. Okay, well, 1 mod 3 equals 1. So if anything was mod 0 before, when I added a 1, it'll become mod 1. So I can take the longest thing that's mod 1. Anything that was 1 before will now become 2 because it's mod 1. So if it was mod 2 before, now it'll become... If it was mod 1 before, it'd become mod 2, but there was nothing mod 1 before, so this doesn't get updated. Anything that's mod 2 before, right? So 3 plus 6 plus 5, that's our longest sum that was mod 2 before. So if we add in a 1, now it'll become mod 3 mod, and then it'll become 0, right? This is mod 3 equals 2. So if I add in something mod 3 equals 1, it'll become mod 3 equals 0. So instead of using 3 plus 6, I would erase this problem. And I'd say, okay, I have something before mod 3 equals 2, and now 1 mod 3 equals 1. So if I attach it to that, it'll become mod 0. So I can attach myself to this and get 3 plus 6 plus 5 plus 1 equals mod 3 equals 0. Okay, now finally, now we have 8, so we can think about something kind of special, because all these have been populated now, so we don't have that weird 0 thing. So 8 mod 3 is what? 2. Okay. So now it's kind of complicated, so let's just walk through our system here, right? So we can attach ourselves to x0, right? So 8 mod 3 equals 2. We can attach ourselves to x0 to get mod 2, which we're going to do, right? Because it's larger than what we have currently, right? The current x2 is less than x0 plus this. So now we can attach ourselves plus 8. Well, I'm really confused now. Hold up. Okay, let's update this in order. So if it's mod 2, x0 becomes the max of x1 plus xm. So the weird thing is it's cyclical, so I'm confusing myself with my own solution. So we're going to update x0, x1, and x2 just for this last one. Okay, so x0 equals the max of x1 plus our new element in whatever it was before. So before x0 was 3 plus 6 plus 5 plus 1. So it was 9, 10, it was 15. But if something is mod 2, 3, if something mod 3 equals 2, and we have some sum mod 3 equals 1. If we add those together, they get mod 3 equals 0. So that means that it would be better to use this sum, right? And then we get 3 plus 6 plus 1 plus 8, right? Which will give you 18. And then x1 equals the max of x2 plus xm, or whatever x1 was before. So it'd be better to use this plus the newest number 8 than use the previous thing. So we get 3 plus 6 plus 5 plus 1 plus 8. And then x2 equals whatever x0 was before plus xm, if it's better. 3 plus 6 plus 5 plus 1. Yep. Plus our newest number. So then at the end, yeah. Whatever. The last two I might have messed something up here. But at the end, you'd return whatever your sum is, whatever the largest sum is, mod 3 equals 0. So you're basically just keeping track of what everything is, the largest sums that get you to some mod number, right? What's the largest sum that gets me mod 3 equals 0? What's the largest sum that gets me mod 3 equals 1? What's the largest sum that gets me mod 3 equals 2? And then I look at the newest number and I say, well, if I attach this newest number to the largest sum equals 0, what does that get me? If I attach this number to the newest sum, the largest sum equals 1, what does that get me? If I attach this newest number to the largest sum, mod 3 equals 2, what does that get me? And that will switch where things are in positions, right? Like, because when you attach something mod 3 to something before where it was mod 1, 0, you get 1, right? But sometimes it flips. When you have a 1 and it used to be a 0, it becomes a 1. If you had a 1 before and you attach a 1, you get a 2. So it's good to have this table. So that's basically this problem. I guess the only thing that we don't capture here is that if there was nothing before, we can't add in the newest number, right? Like when we started with 3, right? I can't put 3 in mod 1 space because there's nothing before it. If there was a 1 here, then I could attach 3 to mod 1 space because it would just shift everything over 1. So, I mean, it would shift everything over 3 would be in the same mod space. Okay. So with that, let's try to just solve this problem. Hopefully all that makes sense. I guess I'll just generalize saying we started by looking at, what does it mean for a number to be divisible? How we can apply this modular argument. So if we have the largest sum modular something, when we add in the newest thing, we can treat them separately. We can find this separately before we solve for the newest thing that we're adding, right? And then we know exactly if we solve the problem in 2 parts, right, where we solve this thing separately prior, we know exactly what will happen when we add a new number, mod that space, and we just exhausted all possibilities, right? And then we use that information to make a decision about what it would mean when we add in this newest number, given information we've solved previously, right? We solved all of this information previously, so when we add in this newest number, what would that mean for the new modular space? And then we just solved an example. So with that, let's try to do this. Let's try. So I'm going to use, I guess I'll use x0, because that's what we did. I kind of want to make this 3 lines, though. No, because it's going to be too confusing for people when they're watching me try to make this obscure. I don't want to make it obscure. Okay, so we'll look at each num in nums. We'll call it x in nums, right? So now we have these cases, right? So we had to decide what we would do based on these cases, right? So if x mod 3 equals 0, x mod 3 equals 1, x mod 3 equals 2. So if x mod 3 equals 0, else if x mod 3 equals 1, and then otherwise, it'd have to be 2. So this would be the 2 case. So if x mod 3 equals 0, how do we update x0, x1, and x2? Well, it's just x0 plus x, the newest number, x1 plus x, x2 plus x, but only if these previous things exist for x1 and x2, right? Because we can't add in the 3 into x1 until there's some sum that exists with x1. Okay, so this is x0 plus x right? And we don't need to take the max because it'll only grow, right? We're not shifting anything. We're not swapping any variables. So if x0 was the max before, it'll stay the max. x1 plus x if x1 else x1. So another way of doing that is you can just say x1 plus int x1 greater than 0. And then finally x2 plus x times int x1 x2 greater than 0. I'll move my head out of the way. I'll move myself down here. Okay. Now what if x mod 3 equals 1? So how does that switch this problem? Well, you'll notice, I'm not going to be able to. So x1 equals 0m, 1n, 2n. You'll notice that the only thing that swaps are the variables here, right? But everything on the right stays the same. So it becomes 1, 2, and 0. One, 2, and 0. But now it becomes a question of deciding if you're going to use x0 plus the newest thing, or you're just going to keep it the same as it was before. Right? If you add something to x0, though, it's not going to change. It'll be the same, so you don't need to consider if the number is whatever you think it is. So the max of that and x2, and the max of this and x0. So I'm just considering what these numbers were before. And then this is the x2 case. And in the x2 case, it's 2, 0, 1. Remember, it's all the same here. So it's 2, 0, 1, which means these change to 2, 0, and 1. And hopefully it makes a little more sense here, right? If it's mod 2, right, if this number x is mod 2, well, now it'll take something that used to be mod 0 and make it mod 2. You just want to check if that's max. And at the end, you just return whatever the maximum thing is that gives you. Okay, I just realized I didn't capitalize these. You should capitalize this, but I didn't here, so it's going to take more time to redo everything here than it would be to just rename these. So since I made a mistake, just bear with me that I give some bad variable names here, maybe. I mean, maybe you don't need to capitalize it. I don't know. All right, cool. So, you can make this a lot shorter. You could actually make this a 3-line solution, right, by just using an array or something, but this is good enough for me. So what's the runtime in the space? Okay, well, let's say that n equals the length of nums. So for time and for space, okay, time is pretty easy, right, because we just have to look at each number, and then for each number, we make a constant check, a constant check, a constant check. There's nothing in here that's dependent on n. We're just, doing some maxes and doing some comparisons and some additions. These are all constant operations. So that's big O of n. And then for space, well, we just create these 3 variables and then we update them accordingly. It doesn't depend on the size of n, the size of nums, right? Whatever n is, it's irrelevant. We only have these 3 variables. So that's O of 1. Okay, so that's it for this problem solution. Hopefully this made a little bit of sense. It's definitely a mathematically involved dealio situation, circumstance. So that might be something to consider when you approach a problem like this, or when you do Leetcode in general, that you're going to have some mathematical knowledge. If there is another explanation, please leave a comment and describe that to me. All right, peace out.